Hello everybody and welcome to the Reuse Company webinars. Today's topic is a practical way to implement ISO15288 V&V processes, the V&V Studio. First, some practical information. You will be muted during the webinar, but if you have any questions or comments, you can use the chat box and add your comments to the Reuse Company host 1. If you have any technical issues, please use the chat box or send an email to support@reusecompany.com. The webinar will be recorded, and in a few days we will send you the link to the recording. My name is Cecilia Karlsson, and I will be hosting today's webinar. With me, I have Juan Llorens, CTO at the Reuse Company, and he will talk about the V&V processes. This is the agenda for the webinar. The webinar information we have already done. Next is a short presentation about the company and the presenter. After that, Juan will talk about the verification and validation processes according to ISO15288. We will see how to automate the verification process and a demonstration of the V&V Studio. We will also take a quick look at our next webinar, and after that, we will have some time for questions. Okay, first a few words about the Reuse Company. The Reuse Company was created in 1999 as a spin-off from a university in Madrid, Spain, by system and software engineers. Our headquarters is in Madrid, but we also have an office in Stockholm, Sweden, and a delegation in Japan, in Tokyo. In 2021, we are planning to open an office in the United States. Our mission is to promote a reusable, scalable, and global solution to a smart and interoperable system engineering environment. And we do this by offering a semantic, knowledge-centric approach. Since the company is a spin-off from the Carlos III University of Madrid, research and innovation is in our DNA, and about 10% of our revenues are dedicated to research and development. The Reuse Company is also actively involved in several large European research projects like Arrowhead, New Control, and Embrace. The Reuse Company is also called TRC. We like to say that it's easy to remember if you think of T like in traceability, R like in reuse, and C or almost Q like in quality. You can also apply these concepts to other topics. Who is using our technology? Here you can see some of the companies that are users of our system. They come from quite different industries like aerospace and defense, energy, automation, and healthcare, but also from other industries. Now let me introduce you to the presenter. Juan is a systems engineer professor at the University Carlos III de Madrid. He is also the CTO at the Reuse Company, and he has been the president of the Spanish chapter of INCOSE. Juan is a member of INCOSE and the Spanish chapter of INCOSE. He has been the chair of the INCOSE Ontology Working Group. He is a member of the INCOSE Requirements Engineering Working Group, and he is a contributor to the INCOSE Guide for Writing Requirements. He also has the CSAP and ESAP certifications. So let's start then with today's topic. Juan, please go ahead and tell us about the V&V processes.
Okay. Thank you very much, Cecilia. Yes, today we are going to talk about V&V processes, a little bit theory in the beginning, and then how the Reuse Company is trying to digitalize this process. So first I would like to say good morning, good afternoon, and good evening to you guys. I hope that you would like we will see. My plan is to spend around 20-25 minutes with slides, and then I will show you a demonstration, some questions after that. Okay, so let's start. I would like to And luckily, to what I usually like to do, I would like to read a little bit things around the different definitions that exist in the standards and the handbook, particularly, as well as in the body of knowledge in some cases. So, the purpose of the verification process is to provide objective evidence that a system or system element fulfills its specified requirements and characteristics. So, I would like just to put the focus here that this definition is nice, it's very good, I like it very much. It confronts a system with requirements, it's clearly clear. If you see these references here, it is stating in which page of the Systems Engineering Handbook that you have here, if you can find this definition. If we put at the same place the definition of the validation process, you will see that it almost starts in the same way, provide evidences, and then it states the system as well, and it start to happen several different things. When in use, fulfills its business, mission, or objectives, and stakeholder requirements. Then here comes again operational environment. So somehow, in a way, it looks like we are faced around the definition in the standard that the system is confronted against two different sorts of requirements. The first one is the system requirements for verification, its own requirements, and then the originating stakeholders for this system requirement for validation. It looks to be quite clear with its the normal way to understand verification and validation in the industry. So it is, I'm sure that you have heard that definition many times. The verification is very much connected with the notion with building the thing right, while validation is very much connected as well with the notion of building the right thing. So that's why eventually it just faces different sorts of work products or requirements, if we say that. So the context is different, yes, and the scope eventually also is different, but both use the same methods and the same tools. So therefore, in this presentation, I'm going to say many times verification and verification. Sometimes I will also remember you that, okay, this is the same for validation, but we are going to apply it everything that you can hear in this webinar is applicable not only to verification, even if I say verification all the time, but also validation. So, what to verify? If we carry on reading after page 83 in the handbook, the next paragraph coming after the definition, it just put the focus that it is not necessary only to think to confront the system against the requirements. You can indeed do verification, you should do verification to everything, every different work product in the systems engineering lifecycle. So the text is just after the handbook just says that you can do verification to requirement, to a requirement, I said again, to a function, an input and output, a flow, a system element, a manual, whatever, procedure, an Excel sheet, you can do verification to whatever you need with the definition that we just said. And somehow, what he's trying to say this is that we don't have to think always on verification coming from right to left. The system, or let's say the hardware part, the touchable part against the left part, which is more abstract. You can also create your own verification procedures for verifying early in the systems engineering lifecycle the left side work products. And it's always coming to the same condition. Why? Because if you verify your left side work product, you're going to have much better quality at the end of the system. It's going to be a kind of investment. Let me put you into a controversy. I'm sure that we have some half of the audience today thinking in one way and the other half in the other one. So this initial definition that I have just said, it is taking me to the question of what is it that I verify? Should I verify the requirements, as we said, against the system? Should I verify the system, and it looks to be in the definition, against the requirements? Because it's not so clear. Indeed, if we just go into different aspects, many people will say, well, the requirement must be verifiable. And then it's clear that I have to verify the requirements against the system. And the other ones just probably said, yes, but what I verify really is the system against some requirements. And then you will ask me, well, you can have here several definitions of what to verify in the body of knowledge. And you can see eventually that, yes, there's something around verifying realized characteristics, which mainly means something touchable against expected design, which something eventually seems to be something in the left side. I personally like much more this way of thinking than that one, but it's not clear that if I like it, it must be that way. And you tell me, why are you getting into this debate? The main reason is because we are a tool vendor, and we are a tool vendor means that we have to provide a system, a software system for you, and in that case, we have to think in which way are you going to think, and this is not clear in which way you're going to think. So in the way to solve this problem in our idea is just please do it in the way you would like. We're going to provide you verifiable item, which is not ours, by the way, it's also coming from the standard, and we are going to provide you the notion of source item and verify the verifiable item against source item. You can decide you yourself if the verifiable item for you is in the right side and the source item in the left, or the contrary. And in the tool, you will be able to face both options. Okay, so how to do verification, how to do validation is the same. Okay, the verification process really stands around the notion of something called verification action. So a verification action is a kind of digital or not digital representation of what is necessary, completely necessary, to provide the evidences that come in the definition of the verification process. So it is a kind of digital form, not digital, in our case it's going to be digital, that should have to track everything necessary for you to provide the evidences and then take the decisions about the final verification. So you have to fill the form, fill the gap, okay? You get all the system, you get the source and verifiable items, and then a way of doing verification is, in a way, usually thought as a very bureaucratic aspect. You have to fill some kind of forms. So at the end, the process, the theoretical part of this talk is the process of verifying something is something like the process of defining, configuring, scheduling, filling, analyzing, managing, reporting, printing, and so on, verification actions. So then, what is a verification action? Well, indeed, it must be whatever you need to be able to verify your element. So there are many, many, many different attributes that you can put in the verification action. I have here in a table with 20-something, 25, 26. There are some of them that I just want to put a remark on. The verifiable item, of course, the source item. And the next one, which will be the verification technique, validation technique. And then, of course, you can have decomposition, you can have phase force strategy, objective evidences of all sorts, resources of all sorts also to describe how is the verification process going, dates, and metadata about it, and many other aspects. Eventually, those that I'm not considering and that for you are very important. Let's get into the verification techniques, okay? There are some of them that are well known in the domain. Let's go and look at them quite quickly. The inspection one. Inspection is usually based on notion of senses. It's the one that is done using our human senses, sight, hearing, smell, touch, taste. And it is a thought of a kind of simple physical manipulation, if any, and no stimuli. You just go there and see if the colors of the aircraft are those that should have to be because of whether the airline have just purchased that. And this is something that you can do through inspection. On the opposite side of the scale, you have the analysis technique, which is the contrary of having something on the senses. It's just to put the abstraction of the humans to work for verification. We do mathematical or not mathematical models that are supposed to model whatever behavior is necessary to be done by a system. And then we are going to rely on these models for assuming that the system is going to have a behavior based on these conditions. It is usually done for simulation purposes, and it's used when the possibility to do this real touching stuff, demonstration or inspection or testing is a little bit more difficult because it's not achievable or it is very expensive to be performed, space, actions, and so on. Okay, if we get into demonstration, this is also a very much hardware oriented, very much to the right side system. You have to show correct operation and observe this operation. Okay, so it's a kind of, okay, if I want to demonstrate that this aircraft is being able to lift with 50 tons weight in the loading part of the cabin, then we just put this 50-ton weights, and then we are going to show that this aircraft is just lifting. So this is quite oriented to right side. Test. It is also very much oriented to do a lot of measurable aspects. We have to measure functional and operability, supportability, performance capability. Everything is measured, but in a way that it is using control conditions. It is usually using specific equipment. I always remember, and I think it is a very nice example for the testing. When I don't know if you guys are aware, I'm sure aware of IKEA, big furniture store, and if you go and traverse the different corridors there, you probably can find one place where one cupboard door is opening and closing unlimited number of times. And it is 455,000 times that the door has been opened and closed. And it is a machine with trying to, in a very controlled condition, open and close the door. Probably not in the same way we usually do it at home, but it is in a way that is testing how it is working. Analogy or similarity, it is a kind of reuse applicable to V&V. Okay, you are going to try to associate verification done to similar products, and you want to make evidences of the possibility to reuse this verification done to a product based on the same way of product and more or less the same way assumable conditions and contexts can be done. Okay, if you have an aircraft that has been certified or verified for flying overnight, and you have never tried to verify that it can fly over day, I presume that this is a stupid example, but you can do that if you need it. Sampling. Now this is very much also oriented to mass production systems where you are using statistical aspects to get into verification by checking and pulling some specific part of the production and doing some statistical aspects on that. Okay, so now we have done definitions of the process, several important topics around it, verification actions and the verification techniques. What is it that the standard describes as the activities for performing the verification process, which, by the way, are the same for the validation one. So we get into a typical IPO diagrams, input, output, and activities, and then we are always controlled by controls and enablers, and the activities themselves in the middle. And these activities are very easy to understand. Well, the standard says that we have to prepare for verification, perform verification, and manage results of verification. For validation, you will see they are the same. So instead of just getting into the standard and showing you and reading what it is necessary in all the different activities, I've just made this kind of summary table. We get into it, and then I will just confront it in the way we can use a tool to do that stuff. So the first thing is for prepare for verification, you have to select the items to be verified. So whatever you want to verify, you have to be able to reach them. And then or at the same time, whatever which way you would like, you have to prepare everything for this verification process, particularly the strategy, which could be quite important, resources of all types, enabling systems, constraints, and so on. Then you have to define verification actions. You have to be able to define how are you going to do the verification process for each verifiable item. If you can replicate these verification actions, as you will see, it could be nice. If not, you have to define one for each one. And of course, among these topics here, you have to define the verification technique. I'm going to put it here specifically for our tool definition later. Around performing verification, what you have to do is you have to execute, you have to populate, fill the information in the verification action. That's it. It's not more than that. Of course, you know more than me, so you know that you know more than that. This is a very expensive activity, but it is what at the end we have to do. And after that, according to what the standard says, you have to be able to define a yes or no. And this yes or no definition, it's based on a very, very stupid and quickly algorithm for decision. And the algorithm is also part of the standard, that you have a reference, and this reference allows you to define expected result for the verification. And on the other side, you have the verifiable item, which is also through the verification action is also recording an obtained result for the verification. And once you have the expected result of all sorts, or the obtained result, you have to do a comparison. You confront these two elements, and based on this comparison, you can have a yes or you can have a no. Okay? This is this algorithm for decision, and just simply can be quite well automated, as you can see it. Just finally to tell you that even if I'm talking about verification, you can see that it is completely applicable. You can get into the standard and you see the definitions that we have gone through it. And the scope is exactly the same. It says in both sides that you have to apply, you can and have to apply verification and validation to whatever product, even in the right or left side of the V model. The activities, you can see that they are the same. The conceptual tool that exists for doing this is the verification action or the validation action, the same. And how to do it is just by managing this verification and validation action. So it is almost the same. Okay, so I'm just okay, excuse me. So I'm just now getting into the how these concepts can be implemented within a tool. The first thing I would like to tell you is that we in a Reuse company like very much to put together the notion of verification, validation, and quality. We consider that they are very much connected. Not only because if you verify at the left side of the V model, you will have for sure much less problems at the right side of the V model, is problems on the sort of quality, of whatever sort, but particularly quality. But it's also because we think that it can be possible to do verification and validation in the left side, eventually in the right side, by managing and using the quality of the different work products. So this is two concepts that we like to put together. How, if you remember, I'm sure you guys know and remember quite well the products around Reuse company. These products usually are very much connected with calculating and managing quality. So I'm going to have this slide, only this slide, for remembering how quality management in RQA, the product tool RQA that we also commercialize, this is handled. So in order to manage quality, we define quality characteristics. Particularly, we like very much to coin the notion of CCC, correctness, completeness, and consistency. In order to manage these characteristics, we define metrics. So you can create quality metrics for a particular quality characteristic. And for this quality metric, we create or calculate a measure. And then this measure, it is confronted against a quality function. If this measure happens to come here, we can give a value for quality, qualitative value. Quality is good. And then what it is just now added to this process is that with these quality values already calculated, we create a quality-based verification decision process. Remember the decision process, you get that stuff here, okay? So then we just try to do this part using quality. So based on these quality values, take decisions about the verification, which doesn't mean to be the same. For example, we can say that when this quality is that level, with the verification is wrong. So to put this together, what we think that it could be applicable also and be included within the different ways to do verification is that, again, we have the reference using in the same way, to provide the expected results. The only thing we have to do now here in this verification action is that we are going to run verification as having inputs for the quality. So we can say here the expected result of the quality to verify the system. And then when we can automatically just extract the quality, if it is the way, and then do the calculations. And in our case, as computers are doing this process automatically, instead of saying yes or no, we are going to have a kind of intermediate yes, suggested yes, or intermediate no, suggested no. And then we put the engineer at the end, just describing if yes or no is proper. So engineer always having the last word here. So let's put some screenshots before we get into the demo. So here we have the different activities that we have to do in the verification and validation process, and then the different actions that we can have. Let's start selecting the items to be verified. So as I was telling you before in the different debates that we have had, you can decide what you want to verify, which is the verifiable item. And in order to do that, in order to say what I want to verify, we just simply use our connectors. We are in Reuse Company connect to many, many different tools. So what we offer here is, please connect to wherever place in the systems engineering lifecycle where you have your verifiable items. And once you connect with them, then you have to define a verification action for each one of them. I will show you then later on in the execution with some screenshots. So the way to do that in a reusable way is just to define some templates. So you can create for once a template for doing inspection where you decide what kind of things you have to do, what protocols you do, what evidences you expect, what kind of videos or whatever you want to include, the way you should have to fill the verification action and so on. And you just do that, and in case you have to verify by inspection 20 different elements, you just simply instantiate this verification action and you just fill it. You can do verification actions, create your own verification actions for whatever you need, for example, checklist or simulations or whatever. You get the verification action here, and then it is in the baseline part, and you can just fill this information that is going to be instantiated later. In the case of the selection of a particular verification technique, you here have all the different verification techniques. You see inspection, analogy, or testing, or analysis, or whatever. Two possibilities occur, and this is interesting for us in order to provide automation for you. So there are some kind of verification and validation techniques that really have to be done by manuals, by engineers. If you are going to do inspection, this inspection must be done in a way manually. We have some experiments with some railway companies where they just put a camera on the train, in a particular train, and then this train just traverses the rail, and then they are just filming everything, all the signals and everything, and then there's a software that is calculating how many signals and at what time, at what mileage it is there, based on image analysis. But this is a kind of modern, very modern inspection today, okay? Most of the inspections usually are done manually. So for those works that you have to do manually, then the only thing we do is we provide verification actions, and then we record and digitalize everything that you put there. So we can define, you guys can define your own checklist, and then we provide this digitalization of the checklist that you can bring in all the information there, and then we do all the records. If you want to fill manually the values for the calculation rule, then you just do it manually. But there are other cases where eventually the verification can be done automatically, always being suggested by the tool. There are three cases. The first one is where you want to do some kind of verification that it is not done manually by humans, but automatically by just connecting to other tools. Because in the main way, you want to connect to tools. For example, you want to run a simulation of a state machine in Simulink, which is possible to do that, or even the same in Magic Draw. Or you just have a very, very powerful model in an FMU for your, I don't know, production or for your whatever part of the system you would like, and then you would like to confront the system against an FMU. These kind of things can be done also within the verification part of the tool. Of course, you can use RQA. So you can calculate the quality in the way that RQA, as you guys know, can do hundreds of different ways for calculating quality, using ontologies and using whatever, all the tools that you know that we have. And then you can use these quality values as a record, or you can create your own one. If you create your own one, then you define whatever you want to do. If you want to do verification by just, or validation by just reading sensors values, you just simply do it just by coding, no problem. So here it is, you just define the way, you can have here the technique, and of course, you can define here, this is automatic rule, if it's a checklist, or if it's a custom action, which mainly means that you are going to create your own. Let's go into perform verification. So in order to perform verification, remember, the only thing you have to do is work with the verification action. So the first thing we have done is, as we decided in the preparation, we defined the connector to the different verifiable items. So the first thing is use the V&V Studio to populate this grid with the information that you want to verify. You can verify requirements, you can verify the system if you have just digitalized in a way, in a PLM or an Excel, and it is going to be then put it together with the information for the verification, as well as if you need with the quality. You will see that in the demo. The second part, once you get access to the verifiable items, is then, if the process is automatic, is then just to run. The only thing you have to do, if you have decided an automatic way of calculating the evidences, is just getting into the different buttons and select the different options. And what the system is going to do is calculate that for you. And in the case of not doing that automatically, to doing that manually, the only thing you have to do is double-click in one of the different elements that exist in the screen and populate and fill the information within the verification action in a different ways. It will show you later on. Okay? And then, of course, then the system, if you have just provided the corresponding information, is going to do the calculation for you. So even if you have filled manually the values in the expected numeric result from the reference and they obtained even manually or even coming from automatic rules, the computer is going to compare these two in the example, in the way the decision process is defined in the standard. And if the computer is doing that, the computer is going to provide a value here. Usually suggested yes, or usually suggested no, or not applicable. One of these three. Okay, and then once everything is done, the computer is going to show you the results in an automatic way. Yes, suggested no, or whatever. And in regards to managing the results of verification, of course, you have to be able to manage evidences in a way, and you have to be able to manage anomalies or whatever is necessary to do. You can report within here everything that you have found within the verification, as well as some other properties like resources spent and person hours and days, so that you can see if it is delayed or it's not delayed, the process. Of course, you have to be able to track in a way not only how it is going explicitly, but also with the typical scoreboards. How is the process going? Which percentage are you getting? How is going with the number of elements treated, or the different resources? How many days or months were you using, and how many do you have in reality? And the same for the money spent or the calendar time and so on. And of course, then you have to provide a kind of baselining. You can be able to create your snapshots along the time, so that the different way of how you see, how eventually everything green going up and the rest going down. What else is necessary according to the information in the standard? Okay, you usually have to manage traceability. There's traceability and reports. Traceability is managed using a traceability matrix in Excel. We just simply put all the information about traceability in Excel. And the same for the reports. For reports, what we do is the report is using Microsoft Word, and what we do is provide a template within Microsoft Word. So you just install the tool and you get a template in Word where you get for you all the different elements. So you write your own documents here, and then you plug one of the elements and play, and you will have your traceability, for example, somewhere, traceability matrix or whatever. Okay, this is the way it works. Okay, I'm done. I'm going to show you now a demonstration, and before that, I would like to give you a couple of advices. The first one is that we have, I don't know if you have heard about it, but we have this philosophical book, what I've been showing you today, 100 pages book. If you're interested, please just demand that book to Cecilia, and we will be happy to provide you a personalized copy of it, digital personalized copy. The second one is that commercial department has just commanded me to put this information here in case you're interested in just piloting this. It would be quite nice if you want to record this specific offer code for just giving it to them, because there will be a reduction of the commercial aspects of money on this piloting. Okay, let's get into demonstration. In order to do that, I'm going to show you a long video around 14-15 minutes where you are going to see how I'm going to work with Excel. In that case, I'm going to open an Excel that is going to cover verification of several aspects, particularly low level, or let's say system property requirements, stakeholder requirements. We are going to verify a critical design review, and we are verify something around some inspection and some analysis or simulation, FMUs, etc. of the system itself. Okay, so let's get into this demo. I will be commenting on it. So here is the V&V Studio. The first thing you can see here in the V&V Studio is that we connect to the, as I told you, we connect to the different sources. If I just go a little bit before again, if I show you here, for example, in this in the tool that I have installed here when I recorded that video, well, I have some connections to Simulink for a breakdown structure. In the case that I would like to verify a PBS in Simulink or in Rhapsody, the same, or I can have a specific other verification aspects. For example, I have also some verification for a Word document, the original Word system requirements document, 200 pages. It could also be as Word document verified. Okay, so in that case, what we are going to do is now connect to one Excel that is a little bit having a potpourri, having a group of all the different aspects that we would like to work together here. A CDR, which is a digitalization of the CDR, is not the document. It could be the document itself, but we are going to work with the digitalization. So the first thing I would like to show you is that V&V Studio includes an RQA. So you're going to see that you can transform the V&V Studio into RQA. You just get the quality view, you get the verification view where you can see all this verified and not verified, a validation view, of course, the full view where you get everything. Quality, verification, and validation. And of course, you get the quality assurance and V&V assurance. In this V&V assurance, you can see here that what we have here is to provide the possibility to define baselines or templates of the verification action. So what you have here is a verification action template. You can open one, and if you open one verification action template, you define how all the different verification actions can be instantiated out of. For quality, it's the same. It's the same than RQA. I'm just putting this here for you to remember. If you remember that, you can assign quality values, and these quality issues are defined as usual using metrics. Okay. So here in the verification part of the configuration, you can assign verification action templates or validation action templates. For example, the CDR, I'm opening now, how are we going to verify a CDR? And we are using, in that case, a CDR verification coming from Raytheon and a CMMI that is public somewhere there. And we are going to define this using a checklist. And as this is the template, what it offers us now is the possibility to feel how everything has to be done, the objective and everything, and of course to manage these different checklist elements. So here, this is a checklist management system. So you can include your questions, and you can define information and rationale around all the different questions. And of course, you later will be instantiating these different checklists. Okay, so we'll see now in a while how it is working. So the first thing then we are going to do, I think, is now we are going to start defining how to work with the CDR. So we want to verify a CDR, and then what we do in Excel, as you can see, just simply that, we create a reference to the CDR. So we say critical design review verification. It is in Excel. You don't have to, if you want, you can have the document there, but for us, it's enough that you just simply reference it. So critical design review verification, you see that you get a suggested yes there. I have prepared that for you because it has 60 or 70 questions. And you can see here in the expected evidence that all the checklist items must be answered as yes. This is the rule for automatic suggestion of verification of the system. So that means that I have just now the instance of the checklist. You can see here, and I have just created not applicable for those titles, and then yes or no. I have just filled for you all these yeses, and you can of course answer just writing your comments and describing for each single of the questions that is demanded for the critical design review. You just put your information there, and as soon as you change a no, you have a no with whatever reason, the system is going to tell you, okay, now I have a suggested no because of it. Remember that you will always be able to define, well, you have history here, everything, every change you do, it is managed and tracked. And of course, you change something when the verification hub is done before, then you get some information saying that it's not, is suspect for the changes. And of course, if you recalculate, you're going to get suggested no, because there's one no in the whole, in the big checklist enumeration that you get there. Okay, put it back, you have some information, yes, everything is yes, and the other not applicable. So when you recalculate that, you get a suggested yes. And of course, you are able now to double click again, and if you want to just go into the human part and you say yes, and you make your argumentation. Okay, all the different aspects that were expected have been fulfilled. I have checked my name is Juan Llorens, I have checked that this is this, and then of course I say that the critical design review is verified today, at that time, at that hour, whatever. You can put images, or you can put links to web pages, or you can put whatever you want as evidences, and then you say okay, you get a green, a real green. Okay, so now let's get into stakeholder requirements. In that case, I'm going to remove the CDR. In that case, now we suddenly get, so I have the menu somewhere there. So you suddenly get 600 requirements, 700 elements, 600 requirements, and we are going to do a verification based on correctness. You see down there, expected quality here, sorry about that, expected quality here, and then you see correctness, and then you see here V&V Studio quality analysis. So this is the way we are going to calculate. We are going to suggest that only offer a suggested yes when the expected quality of the different elements occurring there, in this case requirements, are 3 stars. Okay, and in order to do that, we have defined the quality metrics, typical quality metrics in RQA. Okay, so the only thing we have to do now is just to calculate. So before we do the verification, we calculate the quality, get into the quality view, get into RQA, and then we just run quality. And we are going to set CCC, correctness, consistency, and completeness, in the same way you guys are using RQA. For you who are customers, you don't have to do anything else. That's just the same that you're using your correctness stuff. And of course, everything is applicable. So you have incorrectness, you have here all the information that is happening. And even if the verification is a different process than quality for changing, you eventually have to get into change management and all these permissions and configuration management. But here, if you want, you can apply all these calculations on the quality on the verification. So you will see how can we change different work products in the left side, eventually also in the right side. You can change all these values in order to get a verification, a proper verification. So just yes, we will see now in a second. So, okay, this system is calculating, calculates the quality. In that case, I calculated the quality. Now it's calculating the verification. Okay, and of course, you get a suggested yes only when 3 stars are being gathered from the calculation of the quality. So we are done, and this information comes from this is a European public train specification, and we have just gathered that ones from the Word document that describes this information. Okay, you get all the evidences there, and then of course you would be able to decide again as a human. So we are going to say a yes for something that was a no, and when of course we just make your argumentation again, And once you finish your argumentation, you get a yes for something that eventually was a suggested no. And in a suggested yes, in the same way, you have just the same possibility. You just say no for whatever reason, and then you just describe these reasons, track the changes, of course, who you are and what did you get that, supposing you have permissions, and that's it. Okay, let's get into something a little bit more automatic and interesting. And for you guys who, oh, sorry, yes, before that, let's get into the snapshots and the different states. Well, of course, you just go there and see how the situation is going, how many yeses, how many no's, based on the information that you have filled. Okay, and of course, you get the evolution scoreboard. And you have the choice of also, of course, of creating snapshots. When you think that some good milestone has happened through the verification process, you can, of course, always define a new snapshot, which would be automatically populated in there as soon as you just create a new snapshot there. Okay, now let's get into the properties. And for properties, if you remember, we are going to use again quality management. But in that case, we are going to use quality management based on consistency. So we are going to create a verification action for those requirements based on the notion, you will see down there, that you have to expect 3 stars of quality based on consistency analysis. Okay. So which is the consistency analysis we're going to apply? We are going into the typical, again, RQA configuration. You go and look into RQA and you look for the quality consistency quality metrics. You go there, correctness, completeness, and consistency, and then you have just defined the quality metrics that you're going to apply. In that case, in this case, we're going to use these 4 quality metrics mainly to show you how are we going to do consistency against power calculation of the system. This is the air conditioning part of the train, and we have just in the database, in the ontology, manage a breakdown structure, a PBS, and this PBS is going to be confronted against the requirements describing what is the consumption. There you get the PBS, and what is the consumption of the different parts of the PBS. Okay, so you see, you can read there the maximum power consumption of the compressor shall be, of the fan blade, a heater, whatever, air conditioning system, and so on. So, how to do the verification in that case of requirements? Okay, let's do it again. We go into our RQA and then we calculate consistency. And of course, in this demo, you see there's one consistency problem. You can see there in the consistency stars, there's one requirement saying that it's a big problem. Okay, so if we run verification, okay, I know what's going to happen. If we run verification, then one is going to tell you that it's not verified. Okay, this one is not verified, and the reason, of course, is because it's just some consistency problems. If we go and take a look at the consistency, you will see that the problem is, as you guys do in RQA, we go into RQA, you normally work in RQA and see why this is a problem. So we get into consistency, we get into this metric, and we check what's the problem. And of course, I'm going to do something that is usually not done that way. That's just, it's only for the demo for you to see what's going on. Okay, here's the problem. Sorry. Here's the problem. You see that we have just made all these calculations, the fan blade in different measurement units. We just put all together in the same measurement unit, and I realized that you need 1769 horsepower, and then you just suddenly you get 2. And eventually that was a mistake because you just wanted to put 20, but in a way, some way perhaps you just got 2. So even if it is not possible to do that, I'm going to go into our QA side. I'm going to change this, in that case, requirement at the time. I just change it there. And then, of course, change this requirement. I have to recalculate the quality. And once I recalculate this quality, then, of course, everything is green. And if I recalculate in this demo, it is a little bit didactic. But if I calculate now the verification, of course, I get everything in green, at least suggested green. Let's get, as soon as we do that, let's get into the final part of the demo, which is now we're getting into a system where it's going to do this kind of attempt to automate the right part as well. The first thing we are doing, as we are considering the verifiable item as specifically a definition of the different parts of the system, we have three elements. The compressor must pass the ANSI whatever vibration test. This is something I personally invented. Okay, so please feel free to laugh at me, because what I'm done is just I got some vibrations video somewhere and I just put it there. Okay, so you are testing the system and you have as an evidence this video, and then of course you're going to provide all the graphs, Excel information if you want to put. And interesting in this, this is a testing technique we're using, and we are expecting you, because of whatever, we expect you to have a video. So we expect one video here. When you get the video as an evidence, you just put this one here manually. Okay, this is the way. You just put this manually, and if you put this video there manually, of course we are going to tell you suggested yes, because you have just filled a one, and of course we're expecting a one. In the case of compressor, the same stuff. It is an inspection, and I'm also asking for a video here. So in this case, we are populating the information as well, and this is an inspection of the system. Of course, this is a car, so there's nothing to do, but okay. This just again for demonstration purposes. And then of course you have the choice. Well, you calculate again. I just fill one manually, so this is okay. And the third one is just to show you a little bit more close to our space organization, so you can bring your links instead of just including some videos. In this case, we are using some collaboration with an organization to do some video for drones inspecting aircrafts. Okay, so you can of course run all that stuff, and that's it. No, not big issue here. Okay, it's the same. You just manually put everything there. You put a 1 in the obtained result. You will get a suggested yes, of course. And there's only one more part of the demo, and then we're finished, which is we're going to run this digitalization of the system against an FMU. So we have filled this a little bit more in detail with some expected evidences of how the output voltage of the battery is going to be reduced through the years. And we have some evidences, or we would collect some evidences of running the FMUs. And we define here in the properties, we simply define there where the FMU is and what are the parameters and variables that are necessary to run it as initial values. Define the simulation. And of course, in that case, we have just created this custom. So you can see we just created this code inside the V&V Studio. This is the code that we are going to run. In this case, we are going to run this code to run an FMU. So what to do? We just run, and we have here during 9 years. And what it's going to say, the FMU when it runs is, there's no way. Okay, and the main reason is because this doesn't go through the FMU simulation. So it's tell you that you need something around 7 years, and then of course you just put 9 years. So I'm going to do again something that eventually is not fully done in a verification process, which is I'm going to go back to this specification. I'm going to change, in that case, what I am just verifying. This is 9 years, and then I'm not going to verify it. 9 years, I'm going to verify it, saying that it has to last 7 years. And it's only for demonstration purposes. You will see that now the FMU is going to tell you, okay, you go through. Then if you go through, you will get a green. And of course, you get a green. You have the choice now to say manually after this green, you say, okay, yes, I accept this as a clear evidence because I have just run through the different FMUs for simulation. Okay, you guys, this is everything from my side. I'm going to get back to Cecilia.
Thank you very much, Juan. We'll answer your questions in a couple of minutes. So if you want to ask him anything, please write down your questions in the chat box. You can address them privately to the reuse company host 1, not host 0, or open to everyone. Meanwhile, I will tell you about our next webinar. It's called Writing Perfect Textual Requirements in Capella MBSE Tool, Right Authoring Tools providing real-time CCC assessment and consistency with the underlying model. This webinar presents Right Authoring Tools as an add-on to Capella, thus enhancing a seamless consistency between textual requirements and models. The webinar will include a demonstration of this new add-on showing the following features: assisted authoring of requirements through pattern-based auto-completion, real-time quality assessment, maintenance of relations between textual and model-based requirements, and capitalization of links for change tracking, synchronization of textual requirements, a round-trip approach between Capella and other external requirements management systems. The dates for this webinar are the 16th and the 18th of June. Now, let's see if we have some questions. Thank you for your presentation. You have mentioned several times the product breakdown structure, and in one of the demos, we have seen that the PBS is used to verify a set of system requirements. Does it mean that we have to include the PBS we manage independently in your tool? Thank you.
Okay, thank you. Thank you for the question. The answer is no, you don't have to manage the PBS or to bring the PBS inside V&V Studio. It's enough effort you have to manage the PBS by your side. So what we are usually doing is we are trying to reuse it, which is quite typical from us. So that means that I'm going to show you live. If you just go and connect to the database I use for the demonstration, I say no to the knowledge interfaces. So this is the knowledge management tool, and here in extensibility you have knowledge interfaces, which mainly means that you can connect to different sources to bring inside the ontology on the fly the different breakdown structures. So in that case, for example, we just bring a breakdown structure from IBM Rhapsody. These three are merged within our databases right now in this first one. One from Rhapsody, one from Simulink, another PBS from Rhapsody, and then one Rhapsody model for the train in it. So the answer is no, you don't have to do that. You can easily connect to this information from the outside and use it for your replication.
Okay, thank you. Can you define traceability between the verifiable items and multiple types of source items?
Yeah, okay. Yeah, good question. Traceability is a topic, an issue, of course, all over the different life cycle elements. And here in V&V, of course, it's necessary to be defined because I'm going to open, while I talk, I'm going to open the tool just live, because it connects the verifiable items with the source items. And this means that in a way, you have to provide a requirements verification traceability matrix. So yes, there's no limitation on providing traceability for V&V purposes. If you, of course, have to provide traceability, would like to provide traceability for all different other aspects and V&V, then you have to use Traceability Studio from our side. But in the way to manage traceability, just simply you have the option to select different elements. So you go into verification. And then if you select, for example, one of these copy as V&V source item, and then you get into the different element and you just bring inside the matrix part of the verification action that you get here. So in this source, you just add this item and then you have just made this traceability. And there's no limitation on what kind of different work products can you trace. Yes, that's it. That's a little bit the question. Yep.
Okay, thank you, Juan. We don't have any more questions, so thank you everybody for attending. If you have questions later or if you want more information about our tools, don't hesitate to contact us by email to contact@reusecompany.com or through our website, reusecompany.com. Thank you very much and goodbye.
Thank you. Goodbye.